Okay, greetings one and all, and welcome to day number 2, week 9, spring 2024. That's day number 2, week 9, spring 2024 of our journey together. And it's definitely a delight to have each and every one of you here for this evening's class. We're going to begin. Today is definitely Monday, Tuesday, Wednesday, Tuesday. It is Tuesday the 5th of March, 2024. Our subject is, of course, mathematics. And we're still looking at travel graphs, or you might call them distance time graphs. So distance time graphs. Now, yesterday we learned some terminology for distance time graphs, and we're gonna basically go over that first. That's gonna be the first thing we do, and then we're gonna get into the actual thing that we're gonna be doing for today. Okay, I'm gonna show a graph, and for this one, I want you to draw this, please. So make sure I draw this. Again, make sure I draw this graph in your book. All right, make sure I draw this graph in your book. We're gonna go over this graph before we actually do anything. Before we actually answer any questions, make sure use a ruler and pencil and draw this graph, please. Again, make sure draw this graph. All right. All right, use a ruler and pencil to draw this graph. Let's analyze what's happening inside of this graph, right? So in this graph, we have several portions of things, right? So the first thing that we have, right, is we have this line, right? This line right here. We have this line that is slanting, right? This line that is slanting and it's ascending. So if the line is slanting and it's ascending, is the object moving forward? Is the object at rest? Or is the object moving backwards? What does that mean? If we have a slanted,
It's going forward.
it's moving forward. I only have 2 persons. Where are the rest of you? What happened to the object? What happened to the object if we have a slanted ascending line? What happens to the object?
It's moving forward.
Very good. The object is moving forward, right? Okay, that's the first thing. Now, would we also have, please draw this graph. Again, please draw this graph. Make sure I draw this graph, please. This is going to be our first graph. So now if we have this line, what type of line is this?
Excuse me, Mr. Petit.
What type of
A
line is this?
rectangle.
No,
Horizontal.
horizontal line, right? Goes from left to right. Now, if we have a horizontal line, right? What does that tell you about the object?
That it is resting.
It's at rest.
The object is at rest, or the object has come to a stop. It's stationary. It's not moving, right? So, quick recap. If we have this slanting ascending line with a positive slope, what does that tell us about the object?
It's moving forward.
The object is moving forward. If we have a horizontal line that is flat,
It's at rest.
the object is at rest. Very good. The object is at rest. Make sure please draw this graph. Again, make sure draw this graph in your book. Use a ruler and pencil to draw this graph. All right. Okay, so let's look at something else. If we have this slanted ascending line again, what does that tell you about the object?
It's moving forward.
Descending.
I don't only want these same two persons to answer. The rest of you,
Ascending.
Moving forward.
what's happening to the object?
Moving
Ascend.
forward.
The object is moving forward. Yeah, the object is moving forward. It's moving forward at a constant speed. All right. So if we have a straight line, a slanted line, sorry, that's ascending, that means that the object is moving forward at a constant speed. All right. Make sure please draw this graph inside of your book. Again, make sure draw this graph in your book. Draw all of the labelings and draw all of the times. All right. Again, make sure draw this graph in your book. Now, we have, yet again, a horizontal line. What does this horizontal line tell us about the object?
At rest.
At rest.
The object is at rest.
Is that red?
The object is at rest. The object is not moving. The object is stationary. That's what this tells us. Again, make sure draw this graph inside of your book. How many persons are drawing the graph? Let me know if you're drawing the
I
graph.
I am.
I only have from like 10 persons. Where are the rest of you inside this class? How are you drawing the graph?
I'm drawing the graphs.
Okay, good.
I am.
Okay, good. Alicia McIntosh, are you drawing the graph?
Yes.
Okay, and Kema, are you drawing the graph?
Yes, sir.
Okay, and Omari, are you drawing the graph? Omari, are you drawing the graph? Okay, good. And Tyrone, where's Tyrone? Tyrone, are you there? That's Tyrone. He say he is drawing the graph. Good. Ajani, where's Ajani? Ajani, are you there? Ajani, where's Ajani? I don't know why I have to keep on calling your name.
Yes.
Why do I have to keep on calling your name? I'm asking you, have you drawn the graph? Are you drawing the graph? That's my question.
Yes, sir.
Okay, and okay. Also, Ajani, when we have a horizontal line like this, what does that tell us about the object? If we have a horizontal line, what does that tell us about the object, Ajani? Hello, Ajani. If we have
Yes,
a
sir.
horizontal line, what does that tell us about the object? Do you know or no?
No, sir.
Okay, how about what does a slanting line tell us about the object? Do you know?
No, sir.
Okay, so the slanting line tells us that the object is moving forward, right? And the horizontal line tells us that the object is at rest. So let me try it again. Ajani, what does the slanting line ascending means?
It's moving forward.
Good, and what does the horizontal line mean?
It's at rest.
The object is at rest. Good. Okay, so make sure I draw this graph. when we see a slanting line ascending, where's Amari? Amari, are you there?
Yes, sir.
Okay. When we see a slanting line ascending, what does that tell us about the object?
A slanted line ascending.
Yeah, a slanting line ascending. What does that tell us about the object?
I'm not sure.
I just told Johnny it. I just told Johnny that, so that means you're not paying attention. So Amari, you have to be paying attention inside this class.
Yes, sir.
I literally just told Johnny this the very same question.
I wasn't paying attention. I was drawing.
No, don't give me that. That's a big lie. When we see an object ascending, when we see a line ascending or slanting and ascending, that means that the object is moving forward. All right.
Yes, sir.
And then when we see a slanted line that is horizontal, that means that the object is at rest.
Yes, sir.
So let me ask you again. When we see a slanting line ascending, what does that mean?
The object is moving forward.
Good. And when we see a horizontal line, and
The
it's flat.
object is not. The object is not moving. It's at rest.
Good. The object is at rest. Good. Make sure I draw this for me, please. Again, make sure I draw this for me, please. Now, when we have a line going downward or a line descending, it's still slanted, but it's descending. What does that tell us about the object?
It's going in reverse.
The
Going in
object is-
reverse.
Very good.
It's going in
Reverse.
The object is going in reverse or the object is moving backwards. All right. So if we have an object if we have a line that is slanting and descending with a negative slope, the object is descending. I mean, the object is moving backwards, or it's moving in reverse, or it's returning to the start. That's a better way to say it. The object is returning to the start. All right. Good. Is there any more periods of resting that we have here?
Yes, sir.
Yes, sir.
We have one more period of resting, right? And
Yes,
so-
sir.
So that resting period is going to be right here. This is at rest right now. So a flat horizontal line means that the object is what?
Resting.
Is at rest.
Resting.
Is at
Resting.
rest. And that means it's not moving. It's come to a complete stop. No movement. And then last but by no means least, when we see an object, so when we see a line that is slanting and descending, what does that tell you about it? The object.
It's going in
It's
reverse.
It's moving in reverse.
The object is moving in reverse, or the object is moving backwards, or the object is returning to the start. All right. It's Joseph. By the way, please make sure I draw this graph for me. Where's Joseph? Joseph Kalma. When we see a line slanted and moving and descending, what does that tell you about the object? When we see a line slanting and descending, what does that mean about the object? What the object is doing? If you don't know, just tell me you don't know so you wouldn't waste my time. Do you know?
No, sir.
How about when the line is slanting and ascending? What does that mean?
I remember writing it down, but I don't remember the name of it.
There's the big letter F right there. What does that mean?
There's a big letter what?
F. What does that F means? The F stands for what? The object is moving forward. So like I ask you this again. When we have a slanting line that's ascending, what does that tell us about the object?
Yeah, moving forward.
It's moving forward. Maybe I need to write that down. Forward. When we have a horizontal line, right?
Well, the one in blue means it rests.
Yes, the one in blue means it's resting. That means it's not moving. When we have a line that is slanting and descending, what does that tell you about the object? Slanting and descending, what does that tell you about the object? That is what? Moving backwards. All right? You understand me, Joseph?
Yes, sir.
The object is moving backwards. So what's happening here, Joseph? What's happening here? To the object.
Move backwards.
It's moving backwards. Very good. Jalen, where's Jalen? Hello, Jalen. Where are you?
So,
What is happening when we have a line that is slanting and ascending, like this red line? What's happening to the object?
moving forward.
It's moving forward. What happening when we have a line that is horizontal, flat? What's happening to the object?
Yes.
The rest. And when we have a line that is descending and slanting, what does that tell us about the object?
Moving backwards.
It's moving backwards. Good. And so by the way, please make sure I draw this down, or yeah, draw this graph. Again, make sure I draw this graph for me.
Excuse me, Mr. Battaglia, is it okay that I use my graph book to draw it?
Yes, if you have a graphing paper, that makes it 100 times easier.
Yes, sir. Thank you.
Dante, where's Dante? Dante Davel, are you there? Hello, Dante. For some reason, I cannot hear from Dante. By the way, draw this graph down for me. Because we're gonna answer some questions based on this same graph. So let me move all of these things from here. Udon, where's Udon?
Right, yes, sir.
Why weren't you in class yesterday?
Well, I actually got home pretty late yesterday, so I kind of was mad about that, and I couldn't get to class
Why?
because we came home around like 9 something because we kept stopping everywhere.
Oh, okay, I understand. When it's like that, ask your mother or you have my number to send me a message and let me know, okay?
Yes, sir.
Because you missed a whole lesson and now you don't know. Have you ever done these before? Travel graphs?
No, sir.
Okay. So let me explain to you what I explained to them yesterday. So when you have a line that's ascending like this, that means that the object is moving forward. Okay. When you have it flat, that means the object is at rest. When you have it ascending, that means that the object is moving forward. And then flat means it is at rest. Then when it's going like this and it's descending, that means that you're moving backwards. You're returning back to the start. And this means you're resting. This means that you're returning back to the start. You understand me?
Yes, sir. Thank you.
Good. So that's the basic things you need to know so far. Okay, by the way, make sure draw this graph. Draw this graph and we're gonna answer the questions based on this graph. So let's begin. So the first question is a very simple one. And it says, question part A. How long? So it says that the graph shows an athlete on a run from bridge M to bridge T. And the question is, how long does the athlete stop altogether? How long does the athlete stop altogether? Okay. How long does the athlete stop altogether? That's the first question. So first we have to identify where the athlete stopped. So let's go here. And we have to figure out like where in the world did this athlete stop. I'm gonna make sure I'm gonna put this bigger so you can actually like see what's happening. So we need to figure out like where did this athlete stop. So let's determine that. The athlete stop, the places where the athlete stop was right here. That's the resting phase, right? Is that the only place where it's where the athlete stop?
No, sir.
No, sir.
The athlete also stop right where? Right here, right?
Yes, sir. Yes, sir.
And the athlete also stop right here.
Yes.
Right? So we have all of this time that we have to account for. And we have all of this time that we have to account for. And then we have all of this time right here and this time right here that we have to account for all of this, right? Now, can someone tell me how long you think is this particular one? How long is this? How many minutes is this?
15 minutes.
15 minutes. Why? Because this right here is, well, first of all, this is 10. This is 10:15. Right? This is 10:30. Right? And then this is what, 10:45. So if we're moving from 10:45 to 11, how many minutes is that? From 10:45.
15 minutes.
That's gonna be 15 minutes. Let me ask the question again, because I was not only talking to one person. If we're moving from 10:45 to 11 a.m., how many minutes is that?
15 minutes.
15 minutes.
15 minutes.
15 minutes, very good. Now, how about this one? We're moving from 12 o'clock to 12:15. How many minutes is that?
15 minutes.
15 minutes.
15 minutes, very good. 15 minutes. And is that the only two stops? Or we have
No,
more?
sir.
No, sir.
We have more, right? So how long was this one? We start at 12:45 and we ended at 1:15. So how long was this one? How long was this duration of time? How long was
30
it?
minutes.
30 minutes, very good. 30 minutes. So altogether, right? How long does the athlete stop altogether?
1 hour.
An hour.
An hour, yeah. Because it's going to be what? 30 minutes. 30 minutes. Plus what? Plus 15 minutes. Right? Plus what? Plus 15 minutes. And that's going to be equal to what?
60 minutes.
60 minutes.
60 minutes. And how much is 60 minutes? It's going to be
1
what?
hour.
1 hour.
1 hour.
60,
1 hour.
60 minutes equals to 1 hour. And that's how we're going to get our answer. All right. Where's
Yes, sir.
Daniel? Daniel, are you there? Daniel. What are you working on now?
Pardon me?
What are you working on now?
I was about to send you the stuff.
What topic is that?
Last one was circle down.
Circle theorem. Okay. And what's the next topic that you're gonna go on? You finished all of them?
You got 99?
Have you finished all of them?
Yes, sir.
Circle theorem was the last one.
Send it to you. Pardon me?
I'm
I got
asking is if circle theorem was the last one for week 2.
Yes, sir. Circle was the last one.
Okay, so that means that you need to do mensuration. I'm gonna send you mensuration.
So
All right. I need Andrea. Can you explain how we got 1 hour, please?
Okay, so we're trying to find how long does the athlete stop altogether. So from The first stop is at 11 a.m. So from, I guess from 10, each space between is 15 minutes.
Uh-huh.
So that'll be 30, 15, sorry.
So 10:45 to 11.
To 11 is 15.
Uh-huh.
And then the next stop is 12 by 12.
Mm-hmm.
So that'll be 15 minutes in between that.
Mm-hmm.
And then the next stop is 12:45 to 1:15. And that'll be 30 minutes. And then you add all them up together. 30 plus 15 plus 15 gives you 60 minutes. And 60 minutes is in an hour. So that's how you get
Uh-huh.
your 1 hour.
Okay, good. Very good. Very good. So what do we do? What we do is we have to figure out wherever there's a horizontal line, and wherever there's a horizontal line, that's going to be, where you're resting. So this one is horizontal line, that's the rest. And it's another horizontal line, that's resting. And then this is another horizontal line. So this one right here is 15 minutes. This one right here is 15 minutes, and this one right here is 30. So 15 plus 15 is 30 minutes. Plus another 30 is 60. And then you get 1 hour. Amari, explain how we got 1 hour, please.
You got 1 hour by adding all the times that the person rests all together.
Mm-hmm.
You got it by adding 15 plus 30, which is 45, and then add the next 15, which is 60, and 60 minutes equals 1 hour.
Very good. All right. Do we understand how we got 1 hour? Let me know if you understand how we got 1 hour.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
I need the rest of you who are not responding to answer me because I'm not talking to myself.
Yes, sir.
So do you understand how we got 1 hour?
Yes, sir.
Yes, sir.
All right, good. So we have to add up this 15 plus that 50. Uh-huh.
Not interrupt you, but can you go over that one more time, please?
So where were you? Where were you, Demetria?
I was drawing the thing.
No, you can't be doing that while I'm teaching it. Because then you could ask the same question like that again. I explained it and 2 other persons already explained it. So what you need to do, you need to pay attention, Demetria. You could always get a chance to draw the thing, but you have to pay attention while we're explaining it. Now you don't know what to do.
Yes, sir.
All right. Let me write this down properly because we need space. So to put the working in for you, in order to get it, we have to say 15 minutes plus 15 minutes plus 30 minutes. And that's going to be equal to 60 minutes. And we know that 60 minutes equals to 1 hour. So that's how we get 1 hour for our answer. So for this one, let me just put 1 hour. Okay, so how do we get 1 hour? This portion right here is 15 minutes. This next portion is another 15 minutes. That's the resting part. So that's 15 plus that's 15 is 30. Plus this one right here is going to be another 30. So 15 plus 15 is 30 minutes. and then another 15 plus 15 is 30 minutes again. So 30 minutes plus 30 minutes right here is going to be 60 minutes, and then 60 minutes is an hour. So that's how we get an hour for the number. For how long does the athlete stop altogether? Okay, let's move on to the next question. This is going to be part B.
I can't hear you if you're talking, Mr. Bati.
No, I'm not speaking. All right. The next question says, at what time does he arrive at Bridge T? At what time does he arrive at Bridge T? Okay, so let's look at the graph again. So if we look at the graph right here is where you arrive at Bridge T, right? So what time is that? So
12 o'clock.
this is Bridge T,
12 o'clock.
and we go all the way down, straight down. That's gonna be what? What time?
12 o'clock.
Very good.
12 noon.
12 noon. Very good. So we arrive. Very good. So we arrive at Bridge T at answer. It's going to be 12 o'clock p.m. Let's say noon, so that means p.m. So 12 o'clock p.m. Do you all understand how I got that? Do you all understand?
Yes, sir.
Ew.
Yes.
Yes, sir.
Okay, good. So
Yes, sir.
all we did was we know that they asking us for Bridge T. What time we arrive at Bridge T? So Bridge T is right here. If we look carefully, right there. So he arrived at Bridge T at 12 p.m., 12 o'clock p.m. By the way, make sure draw the graph. Make sure draw the graph. When you send in the image, I need you to have a photo of your graph, all right? So what time did he arrive at the bridge? It would be 12 o'clock p.m. So this is going to be right there, 12 o'clock p.m. That's where we arrive at the bridge, okay? 12 noon.
Mr. Petit, how come it isn't 11? Like, how come it's 12?
Well, at 11 o'clock, he was at rest. That's where he was at 11. This says 11 a.m., right? So at 11, at 11, he was at rest. You see that?
Oh, I see it. Thank you.
Yeah, 12 noon is right there. See what I'm saying? That's what happened at Bridge T. The thing clearly say Bridge T right there. Okay, so the next question is, Um, for part C. At what time does he arrive at rest stop B on the return run? At what time does he arrive at rest stop B on the return run? Okay, so there was a return run. There was a return run, and they asked us what time did he arrive at rest stop B on the return run. So this is rest stop B. This is rest B right here, right? And we're gonna figure out what time he arrives there on his return run. His return run is, so we came down all the way. Then right here is his return run, is where he arrived at rest B on his return run. So right here is the asking us right there. So if we go over, we will see the time that he arrived. So this is right here, rest B, and let's go down right here. The time that he arrived, right? This is the time that he arrived, right here. So this right here is the time they arrive. Notice that this one is 1 p.m. So this one is going to be what?
That would be 12:45.
12:45. Very good. 12:45. 12:45. So again, how do we get 12:45? Well, they asking us for the time that he arrived at rest stop B. So this right here is rest stop B, right? And you know it's rest because it's slanted, it's horizontal. So the time that he arrived there, if we go down, it's going to be 15 minutes away from 1 p.m. So it's going to be 12:45 because this is 12, this is 12:15, this is 12:30, and this is 12:45. So this one right here is going to be 12:45. So he arrived at rest stop B at 12:45 p.m. Do y'all understand that? Let me know if y'all understand that before I move on.
I do.
Yes, sir. Yes, sir.
Yes.
Okay, good. Anyone else understand that before I move on? The time that he arrived at rest stop B.
I do.
Yes, sir.
Good.
Yes.
Okay, good. So we arrive at rest stop B at 12:45 p.m. All right. By the way, make sure you have the graph drawn. All right. Again, make sure you have the graph drawn so that you could be able to look at the graphic on your own when we finish class. All right. So the answer is 12:45 p.m. So we're gonna put 12:45 p.m. That's the time that he arrived at rest stop B. Now, D. Calculate the total distance that he ran. Calculate the total distance ran. But he wants us to figure out the total distance ran. And so for that, we want to figure out the total distance that he ran. Total distance. Okay, so let's figure that out. The total distance that the man ran. The total distance. So if we move from here, right, to here, what's the distance that we run? From 0 all the way up to here, what's the distance, right? That's gonna be what? 5 kilometers. 5 kilometers, yeah, 5 kilometers. And then we go up some more, all the way up. What's the distance here?
11.
11.
No. What's the
12
distance?
kilometers.
If we look at the distance right there, the distance is what?
12.
12. So from the
12.
distance from bridge M to bridge T is how much?
12 kilometers.
12
12
kilometers.
kilometers.
Excuse me, Mr. Petit.
Uh-huh.
May I go to the bathroom real quick, please?
Yes, we can. So the distance from bridge M to bridge T is what? Is what?
12
12
kilometers.
kilometers. So what's the total? What's the distance that he ran?
24.
Who said 24?
1.
Why you say 24?
12 plus 12 because he ran a total distance of 12 ascending.
Mm-hmm.
He ran another 12 kilometers on backwards.
Very good. Very good explanation. Thought I wasn't gonna get that. Very good. So he ran 12 kilometers forward, right? That's going up, right? That's from bridge M to bridge T. But then he had to go back to bridge M, doesn't he? So you have to go all the way down, right? All the way down, right? And so if we go from here downwards, right? That's gonna be another what? 12 what? Kilometers?
Kilometer.
Good. So that means that we have 12 kilometers upwards and 12 kilometers downwards. So what does that mean? That means that his total distance is going to be what?
24 kilometers.
Very good. 12 kilometers plus what? 12 kilometers, which is going to be equal to what?
24 kilometers.
Very good. 24 kilometers. All right. Let me know if y'all understand that. Again, let me know if y'all
I do. I understand.
Okay.
I do.
I
do.
24 kilometers. Okay, good. Hey, you understand how we got 24?
Yes, sir.
Good. Explain how we got 24 kilometers.
We got 24 kilometers because he ran 12 kilometers up and then he ran 12 kilometers down. So we add the 12 kilometers and we got 24 kilometers.
Very good. Angel, are you there? Where's Angel? Angel, are you there? Do you understand how we got 24?
This way.
Explain how we got 24, please.
We got 24 by adding 12 kilometers and 12 kilometers. And that equals to 24. We got 12 kilometers because he ran 12 kilometers up and he ran 12 kilometers down.
Very good.
And that's how we got.
Very good. So towards from bridge M to bridge T, towards that bridge, he ran 12 kilometers and then all the way back is another 12 kilometers. So the answer here is 24. Okay, Aliana, do you understand? And Dion, do you understand?
Yes, sir.
Explain how we got 24.
Okay, so we got 24 because we moved up ascending to 12.
Mhm.
We and then we moved descending to 12, and we added two of the 12s up together, and it came up with 24 kilometers.
Very good. Came up with 24 kilometers. Good. Where's Amari? Amari, are you there? Where's Amari? Okay, no problem. And Ajani,
Yes, sir.
do you understand how we got 24?
Yes, sir.
How did we get 24?
We added 12 kilometers by 12 kilometers, and then we get 24 kilometers.
Okay, why did we do 12 plus 12?
Pardon me?
Why did we do 12 plus 12? Because he ran 12 meters upwards, right? And then going down, how many meters did he tell me kilometers did he run going down?
12.
12 kilometers, very good. Kyle, if you cannot hear us, you have the can anyone else hear us? Kyle, so you can't hear us.
I can hear you.
You can hear us?
Can I hear you?
Okay. Okay, so I guess Kyle, you have to log out and come back in. Okay, so the answer for this one is definitely going to be 24 kilometers because we add the two 12s. So let me and show, and let me put it properly. So we say that the answer for this one is going to be 12 kilometers plus 12 kilometers plus 24 kilometers. All right. So we know the distance for the entire journey is 24 kilometers. What if you want to figure out the total time? So part E says figure out, calculate the total time. So if you want to figure out the total time, right? The total time for the entire journey. What would that be? The total time.
5 hours.
5 hours. Well, we start at 10 a.m., right? Didn't we? And then
Yes,
we ended at what time?
2
2
p.m.
p.m.
2
2
p.m.
p.m.
So 10 a.m. to 1 a.m., how much hours is that? Gonna be 1 hour, right?
1 hour, so that's like 4 hours.
And then 11 a.m. to 12 a.m. is gonna be what? 1
1
hour.
hour.
1 hour.
And then 12 noon to 1 p.m. is gonna be what?
1 hour.
1 hour.
1
And
hour.
then 1 p.m. to 2 p.m. is 1 hour.
1 hour.
So that means altogether, how long was the time?
4 hours.
4 hours. 4
hours.
Wow.
4 hours. 4 hours. Very good. So we say 2 p.m. Right? By the way, let me move all this. Like, so we say 2 p.m. Minus what, 10 a.m. equals to what? 4 hours. And that's straightforward. So again, the time taken for this journey is going to be 2 p.m. minus 10 a.m., which is going to be 4 hours. How did we get 4 hours? Well, we moved from 10 a.m. to 1 a.m. That's 1 hour. We moved from 1 a.m. to 12 noon. That's another hour. We move from 12 noon to 1 p.m. That's another hour. We move from 1 p.m. to 2 p.m. That's going to be another hour. So how many hours altogether? That's going to be what?
4 hours.
4 hours
4 hours.
altogether.
4 hours.
4 hours altogether. Please let me know if you understand how to do E. Again, let me know if you understand how to do.
I understand.
I do.
I understand. I do.
Good.
I do.
So we get that by.
I do.
That's good. We get that by.
Excuse me, Mr. Petit.
Mm-hmm.
For E, will your answer still be correct if you did 10 a.m. take away 2 p.m.?
No, definitely not. Because you have to take away the PM from the AM, because look, 2 p.m. is you always put the final hour last, or the ending time. You always put that. You always put that before you put the beginning time. So yeah, that's how it is. Let me erase this. So it's 4 hours. So the next question that they ask us is, they say, you know what? Calculate. So the last question, this is the last question, by the way, on this. Calculate or determine. This is part E. Calculate the mean speed.
I think you meant part D, Mr. Petit. I'm not D. F.
F. Thank you. Calculate the mean speed for the entire journey.
Yes, Mr. Petit.
Uh-huh.
Can you put the previous slide into chat, please?
Who's asking that for that? Who's asking for the previous slide?
Me.
Johnny, you've been there all class. We still on the same slide. You understand what I'm saying? Still on the slide. We haven't changed it. All right, calculate the mean speed for the entire journey. So you want to figure out. Now, when we say mean speed, what does mean means?
Average, like total.
Total. Mean means total. Anyone else? What does mean means?
The average speed.
Mean is the average, right? The average speed. So here they asking us for the average speed of the journey. And we know how to figure out average speed, right? Average speed is going to be what?
Distance divided by
Distance over time.
Distance over time. Good. So we gotta do that. So average speed is distance over time. So average speed, or in this case, mean speed. So mean speed or average speed is going to be the distance divided by the time. What is the total distance? We just figured out the total distance earlier. What's the total distance for the journey?
12 kilometers.
No, mom.
24.
24 kilometers. Sorry.
24 kilometers. What is the time? The total time?
4 hours.
So it's going to be 24 divided by what? Divided by 4 hours. What is 24 kilometers divided by 4 hours? It's going to be what?
6.
Oh, it's going to be 6.
6 kilometers per hour.
So the answer is 6 kilometers per what?
Hour.
Per hour. Very good. Anyone else understand how we got that 6 kilometers per hour? Let me know if you
Yes,
understand.
sir. I do.
Okay, so 6 kilometers. So the mean speed is going to be the distance over time. The distance is 24 kilometers. The time is 4 hours. So it's going to be 24 divided by 4, which is going to be 6 kilometers per hour. Again, please let me know if you understand how we got 6 kilometers per hour.
I understand.
Yes,
I do.
I understand.
I don't understand.
All right, good.
Excuse me, Mr. Petit. You can explain it for me, please.
Explain it. Okay, so the average speed is distance over time. That's what we mean by average speed, distance over time. The distance we already got, the distance is 24. We got that from part D. That's the distance. The time is the total time. That's going to be 4 hours, which we got from part E. So the total distance is 24. The total time is 4 hours. And so you divide the distance by the time. And 24 divided by 4 is 6 kilometers per hour. And so that's how we get 6 kilometers per hour. All right.
Yes, sir. Thank you.
Good. All right. 1, I need you to explain A through F.
Yes, sir. A says, how long does the athlete stop altogether? Which is 1 hour. So we know that each time that the athlete stops, that's 15 minutes. So he stops once at 11 a.m., which is 15 minutes. He stops at 12 noon, which is 15 minutes. And he stops a total of 30 minutes at 1 p.m. So what we did is that we added 15 plus 15 plus 30, and that gives us 60 minutes. And we know that 60 minutes is 1 hour.
Yeah.
At B, question B says, at what time does he arrive at bridge T? We know that he arrives at bridge T at 12 p.m. because, well, I know, but I can't explain it.
12 p.m.
Sure, yeah, so
That's right there, right?
that's right there.
Okay, good. So that's
So
where
that's
bridge T.
That's all. So
Okay, go ahead.
So B would be at 12 p.m. and C says at what time does he arrive at rest stop B on the return run? At what time does he arrive at rest stop B on the return run? So first we have to find where rest stop B is on the diagram, and we know that I'm trying to explain it.
This is rest stop B.
Yeah, so that's rest stop B.
And that corresponds right there
Yeah,
with,
so
we're trying to find the time, right?
yeah, so at what time does he arrive at rest stop B on the return run?
Good. So
we know that every block is 15 minutes. So we said 15 plus 15 plus 15, which is 45. So we know that at 12:45 p.m. he arrived at rest stop B on return run.
Yeah.
And question D says, calculate the total distance ran. And we know that the athlete ran a total distance of 12 kilometers ascending
Yeah.
at bridge T. And then he ran a total distance of another 12 kilometers backwards. So we added 12 plus 12, which is 24, and that gives us 24 kilometers in total distance that the athlete ran altogether. And question E says, calculate the total time. Calculate the total time. And we know that the athlete started at 10 a.m.
Yeah.
and 10 a.m. At 11 a.m. is 1 hour.
Mm-hmm.
And 11 a.m. to 12 noon, that's another hour.
Uh-huh.
And 12 noon to 1 p.m., that's another hour.
Yep.
And at 1 p.m. to 2 p.m., that's another hour. So that's a total of 4 hours that the athlete ran.
Yep.
Altogether. And question F says, calculate the mean speed for the entire journey. And phrase, we need to find out what is the mean speed. And we know that mean means average. So we know that it's going to be distance over time. So it's going to be 24 kilometers over 4 hours.
Mm-hmm.
You know that 24 divided by 4, which is 6 kilometers. So it's 6 kilometers every hour.
All right, thank you. Okay, good. Very good explanation. All right, the rest of y'all, do y'all understand how we got A through F? Let me know, please.
Yes. Yes, sir.
Yes, sir.
Yes, sir.
All right, good. Let's go ahead and do a grade exercise then. So, I guess someone need this photo inside the chat. So let me put it inside the chat for you. Those persons who would need it. All right. It's gonna be the grade exercise. For the grade exercise, I need you exercise number 1, I think. Yeah, number 1. So this is your graph. And these are your questions. For this one, do not, I repeat, do not draw the graph. I repeat, do not draw the graph, only write down the questions, all right? So should we draw the graph?
No,
No,
sir.
sir.
No, don't
No,
draw the
sir.
graph.
No,
Don't draw the graph, only answer the questions, all right? Only write down the questions and answer them. All right. Again, do not draw the graph, only answer the questions. What's his name? Amara, you understand what you're doing? Where's Amari?
Yes, sir.
Do you understand what to do?
Yes, sir.
Remember, do not draw the graph.
Yes, sir.
Give me one moment. Let me switch something. Let me switch something. And Akiro, where's Akiro? Akiro, are you there? Where's Akiro?
Yes, sir.
Are you on the grade exercise or are you still writing down the notes?
I finished the notes. I'm doing the graded exercise.
Remember, do not draw the graph, only write down the questions and answer them.
Yes, sir.
You get the when you send in a picture of your work, make sure to take a picture of your notes as well as the graded exercise. So take a picture of your notes as well as the graded exercise. It's gonna be F. Okay, good. These are your questions based on this graph. Again, do not draw the graph, only draw the question, only write down the questions and the answers. Alicia, what number you want? Or not letter, sorry.
D.
B. And Alicia, what letter are you on?
E.
Pardon?
Letter E.
Letter E. And Aliyah Star, what number you on?
D.
D. And Aliana, what number you on?
I'm drawing a graph.
Aliana, I said do not draw the graph. I said it like 300 times. Are you listening, Aliana?
Yes, sir.
Class, how much times I said don't draw the graph?
A lot.
I said it like a 1,000 times. Do not draw the graph, Aliana. Just write down the questions and the answers. You hear me? I said, do you hear me, Aliana?
Yes, sir.
Okay. And Amari, what number you on? What letter, sorry? Are you on?
C.
C. Andrea, what letter you on?
E.
E. Okay. Angel, what letter you on? Angel, what letter you on?
E.
Okay. And Ashani, Fernanda, what letter you on? Ashani, Fernanda, what letter you on?
She typed in chat.
She said D, okay. And Renee Russell, what letter you on?
One.
Say it again.
One C.
C, okay. And Bethany, what letter you on? Bethany, what letter you on?
Letter C.
Letter C, okay. And Brianna, what letter you on? Brianna? Where's Brianna? Brianna Roll? I can't hear from Brianna. Brianna, are you there? Brianna Roll. Bree and Bri, what number you on? What letter y'all on?
Yes, sir.
Yes, I'm asking what letter you on, Brianna.
I'm on B.
B. You understand what to do?
Yes, sir.
Okay. And Bree and Bri, what letter y'all on?
E, sir.
B. Okay. Bri, what letter you on? Give
E.
okay. E, okay. Give at Presenti, what letter you on?
I'm on number C.
C, okay. Again, once you finish with your work, take a picture of it and send it to me via WhatsApp again. Once you finish with your work, take a picture of it and send it to me via WhatsApp. Chai, what letter you on? That's Chai.
C.
And China, what letter you on?
E.
Okay. Ciara Rackley, what number letter you on? Ciara.
F.
F, okay. And Dari, what number letter you on?
I already finished, but the only reason I sent my work yet is because my mom was some type of conference, something. I don't know.
Okay. Once he's finished, take a picture of your work. Demetria, Edgecombe, what
Yes,
letter you
sir.
on? What letter you on?
F.
F. Daniel, what are you working on? Daniel. Where's Daniel? Where's Daniel? Where's Daniel? Can I have from Daniel? Tia Gibson, what number you on? E, okay. Again, for those of you who are finished, for those of you who are finished, take a picture of your work and send it to me via WhatsApp. Again, for those of you who are finished, take a picture of your work and send it to me via WhatsApp. Dior Ramsey, where's Dior?
Yes, sir.
What number you on, Dior?
I'm finished.
Okay, take a picture of your work and send it to me, including the notes.
Okay.
It's either yes or no, sir.
Sorry.
Yes, I need you to do that, Daniel. Daniel, I didn't see your circle theorem. You sent me, tell me he's gonna send that. Where is it? Dante Davel, where's Dante?
Yes, sir.
Dante, what letter you on?
I'm on E.
Okay. And Doranique, what letter you on?
E.
E. Okay, good. Again, for those of you who are finished, take a picture of your work and send it to me via WhatsApp, please. Make sure when you're sending your work, send also the notes as well. Egypt, what letter you on? Egypt, what letter you on? Say it again.
C.
C, okay. And Evanice, what letter you on?
E.
Aliyah Store, what letter you on?
F.
F. And Gilbrianna Goodman, what letter you on?
D.
D. Good. You Don Roll, what letter you on?
E, so
E. Jalen Butler, what letter you on? Where's Jalen? Jalen Butler,
Yes, sir.
what letter you on?
And letter C.
C, okay. And Jevin Moss, what letter you on?
Letters D.
D, okay. And Jeremy, what letter you on? Where's Jeremy? Jeremy Langs, what letter you on? Jeremy Langs, are you there? How about Juan? Where's Juan?
Yes, sir. I'm on F.
You're on F, okay. And Casey Hamilton, what letter you on?
I on D, sir.
20, okay. And Kma, what letter you on?
I'm a B.
You on B? Kma, where's the notes from yesterday?
I sent those from yesterday.
Using whose phone?
Pardon?
Using whose phone? Using whose phone? I don't.
My mom's phone.
Oh, okay, I see. And Kingston, what letter you on?
I on letter E.
Okay, good. I'm still waiting for the rest of you to send in your work. Again, once you finish, take a picture of your work and send it to me via WhatsApp. Kiajane Bethel, where's Kiajane? Kiajane, are you there? Hello, Kiajane. What letter you want, Kiajane?
She just left the meeting.
Okay,
She left.
okay, thank you. Um, Malia Roll, what letter you want?
F.
F. And Kyle, what letter you want?
I'm about to finish the notes, sir.
You about to what?
Finish the notes.
So you haven't reached the grade exercises yet?
No, sir. I couldn't hang on for like half of the lesson because of my device.
You get ours now, right?
Yes, sir.
Okay, well, quickly finish.
Yes, sir.
And Malik Roll, what letter you on?
I am finished, sir. I'll send in the rest of the notes to you right now, sir.
Okay. And Mark, what letter you on?
On letter F.
Letter F. Okay. And Michael, what letter you on?
E.
Letter E. And Mila, what letter you on?
Letter D.
Letter D. Good. Nakari Roberts, what letter you on?
Letter C.
Letter C. You understand what you're doing?
Yes, or something like that.
Okay. Nevia Wallace. Where's Nevia? Nevia Wallace? Nevia Wallace? Where's Nevia Wallace? Nevia Wallace, where are you? Can't have from Nevia. Nivea Gordon. What number you on? What letter, sorry.
I'm on letter D.
Letter D. And Olivia, what letter you on? And Olivia?
Send in the notes, Mr. B.
Send in it now, okay. Omari, what letter you on? Omari? As Omari. Say I'm done. I send you the notes, okay. Good. And Randisha, what letter you on? Randisha? Number F, okay. And Ricardo Russell,
Yes, sir.
what letter you on?
D.
D?
Yes, sir.
Okay. And Ronisha, what letter you on? Ronisha, what letter you on? Where's Ronisha? Ronisha, are you there? Where's Ronisha? I can't hear from Ronisha. Sabria, what letter you on?
Pardon me?
What letter you on?
I'm on F.
You're F, good. Sadal, what letter you on? Sadal, what letter you on?
I am on E.
E?
Yes.
Pardon?
Yes, sir.
Okay. Once you finish with your work, take a picture of it and send it to me via WhatsApp. Samantha, are you finished?
Yes, sir.
How about you, Shakaina? Shakaina Kalma. Shakaina Kalma. Where's Shakaina? I can't hear from Shakaina. Antia Minas.
Yes, sir.
What letter you on?
I sent you my work already.
You're done? Okay. I have Andrea, Amaranik, Bri, Aliyah, China, Alicia, Olivia, Teo, Omari, Bethany, and Samantha. I don't have all of your stuff. I don't have all of your stuff.
I sent them right now.
Okay. The rest of you need to take a picture of your work and send it to me via WhatsApp. Ronisha. I've been calling you for the longest since I class and you're not responding. No, you couldn't have the step away, because if you had the step away, you would have informed me before you go. That's what you would have done. That's what you would have done. Make sure if yeah, but you're supposed to let me know. You can't just exit and don't let me know. Now I'm calling your name in vain and anyway, what letter you want? Pardon? Okay. Quickly finish and then send the notes and also the grade exercise. Okay. Amari, what number what letter you on? Amari, Makfi. Amari, where's Amari? Amari Makfi, there's only one Amari in there. Where is he? Gone with the wind. Again, when you finish your work, take a picture of it and send it to me via WhatsApp. I only have a few persons work. I'm still waiting on the others. I don't know why this thing is taking y'all so long. Again, I need the rest of your notes, please. Take a picture of it and send it to me via WhatsApp. Ajani, what letter you on?
C.
Pardon?
C.
C. Okay. And Alicia, are you finished? Alicia? Where's Alicia? Alicia Thomas?
Yes, I'm finished.
Why it's taking you forever to answer? What's happening? Alicia, are you finished?
Yes, sir. Sorry, Mr. Petit. My laptop started glitching.
Okay. Alicia, you say you finished, right?
Yes, sir.
Okay. Anyone else finished besides Alicia? Anyone else is finished besides Alicia? Anyone else is finished?
I'm standing in my work right now.
So only 2 persons are finished besides Alicia.
I'm
I'm
done. I sent in mine in right now.
Okay. The rest of you need to hurry up because this shouldn't take you forever. Again, once you finish your work, take a picture of it and send it to me via WhatsApp. Take a picture of your notes as well as the grade exercise. Aaliyah Store, are you done? Where's Aaliyah?
Yes, sir.
Good. Aliana, you finished? Where's Aliana? Aliana, you done? Why can't I hear from Aliana? Aliana, can you hear me? Can't hear from Amara. Nick, you finished, right?
Yes, sir.
Okay. And Andrea, you're done as well?
Yes, sir.
Okay. Angel, how about you? You finished? Where's Angel? Angel Cooper? Hello, Aliana. Yes, I'm calling you in the chat, but you're not responding.
I didn't hear. Sometimes it is break up.
Okay, I'm asking what letter you want. E, okay. And Renee Russell, what letter you want?
I'm done.
You're done. Have you sent in your workers yet?
I will right now.
Okay. All right. Who else? All right. Bree and Bri, are y'all finished?
Yes, sir.
Okay.
I'm not finished yet.
Have you sent in your work?
Yes, sir, I have.
Okay. And okay, that percent, what letter you on?
I'm on D.
D, okay, good. Chai, are you finished?
I'm on the last question.
Okay. Where's Brianna Roll?
Yes, sir.
They asked for the average speed. How come you didn't answer that?
Oh, I can answer it right now.
and Kingston.
Yes, sir. I send my work right now.
Okay. And Daniel, what are you working on? Where's Daniel? Daniel, are you there? Where's Daniel? Um,
Yes, sir.
what are you working on?
I was watching the video. I ain't started writing on yet. I was just watching the video.
Okay. But you can't just watch it first. You have to watch and write because I'm gonna need some
Oh, at the
notes from
same
you.
time.
Yes, you have to do that.
Yes, sir.
Where is what's her name? Renee, where's F for the average speed?
I
Where
just
is
realized that. I'll send that right now.
it? Okay. All right, thank you, Aaliyah. And I'm still waiting for the rest of you to send in your notes. I don't know why y'all taking so long. This thing is not hard. And Michael, what number you on? What letter you on, Michael?
I finishing up now. I put the send to you.
How about you, Dion?
I'm on F.
Okay, and Doranique, what letter you on?
I'm about to send it.
Okay, and Evanice, what letter you on?
On F.
On F. Okay, good. Kiajane, what letter you on? Kiajane. And Udon, what letter you on, Udon?
I'm on letter E.
Letter E. Okay, Jalen, what letter you on? Jalen. Letter you on?
E.
E, okay. And Malia Roll, are you finished? Where's Malia? Okay, still waiting for the rest of you to finish. I don't know why y'all taking so long. This is a very easy exercise. Let's go ahead and answer these
Excuse me,
questions.
Mr. Patek, did you call me?
Yes, I called you.
I was telling you that I'm here.
What letter you on? That's what I want to know.
F.
F, okay. Okay, let's go ahead and answer these questions. I want to know what y'all have for number for letter A. It says, at what time did the car leave Haley? What y'all have for that one? At what time did the car leave Haley? What y'all have for number for letter A?
10 o'clock.
10 o'clock.
I'm not only talking to 2 persons. I'm talking to the whole class. What time
I
did
have
the car leave Haley?
10:30.
10 o'clock.
10:30. I got 10:30.
10:30.
Why would you say
I have
10:30?
10:15.
10 o'clock.
What time did they leave? It started right here, so it left at 10.
10 o'clock.
Right, so they asking for the 10 o'clock, the starting time. So the answer is 10 o'clock. How many persons have 10 o'clock? Let me know, please.
I do.
I do.
I do.
Only 3 persons. Anyone else have
I
10
do.
o'clock?
I do.
I have 10:30.
It can't be 10:30 because that's when we're talking about
I
the
have
starting
10
time.
o'clock.
10 o'clock is the starting time, right? How far is it from Haley to Matic? How far? How far is it from Haley to Matic? Which all for that one? The distance.
100 kilometers.
100 kilometers.
100 kilometers. Very good. 100 kilometers. Anyone got 100 kilometers? Let me know if you got 100 kilometers.
Yes, sir.
I did.
Good. 100 kilometers is the correct answer. Because they asking you, how long is it from Haley all the way to Matic? All right. Anyone got the first two correct? Let me know if you got the first two correct.
I did.
I did.
Good. I'm still waiting on the rest of person's notes. I need you to take a picture of your notes and send it to me via WhatsApp again. Take a picture of notes and your grade exercise and send it to me via WhatsApp. The next question is how long did the car stop in total? How long did the car stop in total? So what we have here is it stopped here, right? And how much is that? That's going to be, this is 11, 15, this is 11:30, 11:45, 12 o'clock, right? So how much minutes is this one? It's going to be what? 30 minutes, right? And then for this one, how many minutes is that?
That's 15 minutes.
15 minutes.
It's 15 minutes, right? So 30, right? Plus 15 is going to be what?
45.
45.
45.
So 30 minutes, right? Plus what? Plus 15 minutes.
15 minutes.
So 30 minutes plus 15 minutes equals what?
45 minutes.
45 minutes, right? 45. So the answer is 45 minutes. How many persons got 45 minutes? Let me know if you got 45.
I do. I did.
Yes, sir.
Okay, good. 45 minutes. Only 4
I
persons.
did.
Anyone else got 45 minutes? For
I
the
did.
total stops. Okay, good.
I did.
Good. I'm still waiting on the rest of people to send in their work. At what time did the car return to Haley? What time did the car return to Haley?
2 p.m.
What time?
2 p.m.
2 p.m.
It says 14
2.
o'clock. So you could
14.
14 o'clock or you could put 2 p.m. Both of them is the same thing. So either one works. If you have 14 o'clock or 1400 hours, or you have 2 o'clock, both of them are correct. Anyone have that answer?
Yeah.
So
Good. What's the time that it arrived? It returned back to Haley. So it started by Haley at 10:30. I'm sorry, at 10 o'clock, and arrived back to Haley at 2 p.m. Calculate the total time taken for the journey. For that one. A total time.
4
4
hours. 4 hours.
4 hours. Very good. So from 10 to 11, that's gonna be what?
1
1
hour.
1 hour.
1
From
hour.
11 to 12, that's what?
2 hours.
1 hour.
1 hour.
2
And then from 12 to 1, that's another 1
1
hour.
hour.
From 13 to 14, that's another 1 hour, right? So if you have 1 hour plus 1 hour plus 1 hour plus another hour, that's gonna be what?
4 hours.
4 hours.
Very good. So 14 o'clock. Minus what? 10 o'clock equals to what? Close to 4 hours. Now for number, by the way, anyone got E right? Anyone got E right? 4 hours.
Yes, sir.
Okay, good.
I did.
So E is 4 hours. Now the big question, it says calculate the average speed for the entire journey, including the stops, right? So the speed, the average speed for the entire journey, how are we gonna get that? Average speed is gonna be what? Average speed, average speed.
Distance over time.
Average speed, we said average speed is going to be distance. So average speed is going to be the total distance divided by the total time. So average speed for the entire journey, right? What is the total distance?
100 kilometers.
100 kilometers.
Wrong.
I got 200.
200 kilometers.
200 kilometers. Why is it 200 kilometers?
Because 100 going
Because when you 100 plus 100.
to Maytech and
Very good.
the
100,
next one.
100 going up, right? And then 100 coming back down. So altogether, that's going to be what?
200.
200. So it's going to be
200 kilometers.
average speed is going to be 100 plus what? 100, which is going to be equal to 200. And what's the total time?
4 hours.
4 hours, yeah, 4 hours. So it's going to be equal to 200, right? Divided by what? Divided by 4. What is 200 divided by 4?
50.
What is 200 divided by 4?
50 kilometers per hour.
It's going to be 50 kilometers per hour. So 50 kilometers per hour.
Did you include the stops?
Yeah, include the stops, yeah. Because the stops includes all of the time, because if I didn't include the stops, then I would have minus 4 hours from 45.
Right. That's
Yeah.
all.
Good. So it's going to be 50 kilometers per hour. My person's got that 50 kilometers per hour.
I did.
I did.
I did.
I did.
I didn't because I forgot to count it going up and going down.
Okay. Okay. Anyone else got that? 50 kilometers per hour. Anyone else got that? 50 kilometers per hour. Let me know if you got it.
I did.
I did.
Okay. I'm still waiting on the rest of the notes from you persons who are still working. I don't know why it's taking us so long to send these notes. All right. Anyone got all right? Anyone got all right?
All right.
Yes, sir.
Anyone
Yes,
got
sir.
all right?
No, sir.
Anyone got all right?
No. Yes, sir.
Yes, so I did.
Okay. If you got all right, put I inside the chat. Again, if you got all right, put I inside the chat. Anyone got one wrong? Anyone got one wrong?
I did.
I did.
Okay.
I did.
I did.
Okay. If you got one wrong, put Y. If you got two wrong, put N. So for the persons who got all right, put I. The persons who got one wrong, put Y. And the persons who got two wrong, put N. All right. Good stuff. Wow, a lot of persons got one wrong. Very good, Brianna, Reckley, Kevin, Alicia, Dia, and the rest of you. You have a lot of Ys, like a lot of Ys. What did y'all get wrong for those persons who got one wrong?
F.
F.
The last one. The last one. Okay. I guess what you did, you didn't count the time going forward and backwards.
Yes,
No,
sir.
sir.
Andrea, how did you get 2 wrong?
No. The last one, Mr. Petit, and the first one, because I put 10:15 instead of 10 o'clock.
Oh no, they asked for the starting time.
Yes,
Okay.
sir.
Yeah, don't overthink it, right?
Yes, sir.
Okay, good. Okay, so let's do a quick one. So let me take a screenshot of this, put it inside the slide. Those persons who are still working. Oh, you put 10:30, okay. So what do you think about time graphs? Do you like them or you hate them? Easy, medium, hard, what you think?
No, sir.
I hate them.
Easy.
I
I
hate
don't
them.
like it.
You like it? Easy, medium, hard?
I think I
I
like
hate them.
it. Like certain
Okay.
parts, I just is
I like
overthink
it.
what I do.
I don't like it.
You don't
I
like it?
dislike.
Oh, wow. So do you think it's an easy topic in math or it's not easy or it's medium?
Medium.
Medium?
Easy.
Medium.
Medium. It's not easy.
Not easy. Okay, interesting. I mean, all you gotta do is look at the graph. Look at the graph and interpret it. And then you're good to go. We have 8 minutes, so that's for those of you who are still working, take a picture of your work and send it to me via WhatsApp. For the rest of us, let's do one together. This is let's do one. Let's do this one. This one look interesting. So okay. So this one says, so here we have distance from what is this? Perez house. Okay. Do not write this down. We're just going over it quickly. We have time in hours. So this one is 0, then this one is half an hour. How many minutes is half an hour? How many minutes is half an hour?
30 minutes.
30 minutes.
I cannot see your screen.
30 minutes.
Oh, you can't see my screen. So that means let me see something. Stop sharing. Let me share this then. Can you see it now?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, good. Okay, good. So say I don't like it. Okay, so like we say half an hour. So this, you don't have to write this down. We're just going over it quickly. So how much distance was traveled based on this graph? How much distance was traveled? So do you see?
90.
90 miles.
Yeah, 90 miles. 90 miles
90
because
miles.
it's 90 miles because this right here, all the way up here is 90. So that's 90 miles, right? And that's the total distance. Start from 0, go all the way up, all the way up, all the way up, all the way up to 90. So that's 90. That's good. And then, okay, that's that. How many, and then half an hour. Half an hour is how many minutes is half an hour?
30.
30 minutes.
30 minutes.
30.
1 hour is what? 60 minutes?
60 minutes.
60.
And then an hour and a half. How many minutes is an hour? It's an hour and a half.
1 hour and 30 minutes.
Hour and 30 minutes.
Hour and 30 minutes. And then 2 hours, how many minutes is that?
2 hours. I mean,
How many minutes? It's 2 hours.
20 minutes.
120 minutes.
120 minutes, good.
20.
Okay, so let's go ahead and answer the questions. So again, you don't have to write this down. We're just going over quickly. The graph shows Perez's journey from his house to his grandma's house. First question is how long as time did it take to travel the first 20 miles? So let's go back to the graph. How long did it take to travel the first 20 miles? What that's going to be?
30 minutes.
30 minutes.
30 minutes.
30 minutes.
Yeah, 30 minutes
30
because
minutes.
this is 20, right? And then come down here. Come down there. So that's a half an hour, which is 30 minutes. So this and that. All right. 30 minutes. So the answer for that one is 30. That's pretty simple. Clear all drawings. How long did Perez stop for after traveling for 1 hour? How long did he stop? So we traveled for 1 hour. How long did we stop?
30 minutes.
30 minutes.
So this right here, right? So this right here is 1:15. This right here is 15, 30, no, 45. No, look like we going in tens because this is what?
5 minutes. 10 minutes.
10, 20, 30, 40, 50. Wait. 1.
3 and 5s.
We're going to fives, yeah. Because this is 1, this is going to be 105. It's going to be 110, 115, 120. Is that so? I think right.
I think we're going to tens.
We're going in 6. We're going in 6s. Because remember, this is 30 minutes, right? So if that's 30 minutes, that means that, let me just zoom it in for you. Let me just leave it.
So we travel like 18 minutes.
So this is 6, right? Because that's 1 and this is 6. And then this is another 6, so it's going to be 18. And then another 6 is going to be 24.
Wouldn't it be 6 then 12?
6, then 12, yeah. 6, 12. So 6, then 12, right? Then 18. Then what? Then 24. Then 30. You see that? See how we got the 30, right? Each one of them is 6. So this is 6. And then this is going to be 12. And then it's going to be 18. It's going to be 24. It's going to be 30. Y'all understand that?
Yes, sir. Yeah.
So not every time we counting in, 15s. So how long did he stop? Right?
12 minutes.
We're covering this whole thing. So we know that but we know that this is 6. We also know that what? This is also 6. So how long did he stop?
12 minutes.
How long did he stop?
12 minutes. 12 minutes.
12 minutes. Very good. 12 minutes. So that means that, let me erase all this. Clear all drawings. That means that how long did Perez take to travel the first 20 miles? He took what did we say for the first one? He took 30 minutes. So the answer for this one is 30. So we took half an hour. Right? And then how long did Perez stop after traveling for 1 hour? He stopped for 6 minutes plus 6 minutes. It's going to be what? 12 minutes. Okay, it's 8 o'clock, so that means that we have to move on to health science and general science. If you are not doing health science and general science and you're already sending your work, then you can leave. But those of us who are doing health science and general science, we have to stay, all right? Again, if you are not doing health science or general science, you can leave once you've already sent in your work. But for those of us who are doing health science and general science, please stay back. All right. Clear all drawings. Okay, let's go. Let's move on. All right, so let's move on to, let me stop sharing and then share again. So this is gonna be for health science, and then we're gonna go on to general science. So the talk today is, let's head up properly. Today is Tuesday. Tuesday the 5th of March, 2024. The subject is, of course, in health science, I think. Health science. The topic is, of course, so the last time we were talking, the last time we were on health science, what were we looking at?
Muscles working together.
Very good, muscles working together, and we dealt with, we talk about muscles that work together, but they work together in an opposite way. What do we call those type of muscles? What do you call those type of muscles? They work together, but in the opposite way.
Antagonist.
Voluntary muscles?
It's not with A.
Antagonistic pairs.
Antagonistic pairs, very good. They work together, but they work together in opposite way. Give me an example of an antagonistic pair.
When one relax, the other contract.
Give me an example of one.
Bicep and tricep.
The biceps and who said that?
Mila.
Sound like Mila, where's your work? Your notes from maths.
It's in.
You sent it?
Yes, sir.
Okay, good. So the biceps and the triceps is
Bicep and tricep is right though.
that is correct, yes.
Thank you.
Biceps and triceps is an example of antagonistic muscles. So when the biceps contract, the triceps is gonna do what?
Relax.
Relax. And then when the triceps contract, the biceps are gonna do what? When the triceps contract, what the biceps gonna do?
Relax.
Relax. Relax. So today we're gonna be looking, very good. Today we're gonna be looking at like disorders of the muscular system. Or we could say diseases, or we can say, yeah, diseases that affect the muscles, right? Diseases that affect the muscles or disorders of the muscular system. So there are many diseases or malfunctions that may occur in the in the muscular system, right? Several are listed below. Several are listed below. So the first one is what we call polio. Now, polio is caused by a pathogen. A pathogen is basically a microorganism that affects the body in a negative way, right? And it's a It was a viral pathogen, and it was very devastating. Now, anyone ever saw pictures of people who were impacted by polio? It impacted a lot of people back in those days, but nowadays it don't affect a lot of people because they found something to be able to treat it and stuff.
It looked painful, honestly.
Yeah, polio. Anyone have ever saw it? It's basically when you are basically when you it basically affects your spinal cord, yeah. So your spine is out of whack, right? It causes paralysis, so you can't move your body parts, right? And you end up, not being in a good condition. So let me show you an example of it so you guys can see. So this is an example of people who have polio. As you can see, not good, right? It's a disease of the nervous system, and it destroys the nerve cells embedded in the muscle, right? So the muscles don't get the messages sent. And so what happens is the muscle atrophies, so it becomes basically useless. And the persons who with this, they get paralyzed or they might end up dying. All right, so certainly not a good disease to have, right? Polio. So let's describe it. So this is this disease is caused by a viral pathogen, and it was most devastating. Write this down for me, please. For hundreds of years, but is virtually eradicated now in more than half of the world today. Right? So this is a disease of the nervous system. It destroys the nerve cells embedded in the muscle, so that the muscle does not get messages and atrophy. So when you don't use something that atrophies, it basically becomes useless, right? Becoming useless. Persons with this, they end up being paralyzed, right? So persons with this disease may become paralyzed, or they may die. So when you end up with polio, what end up happening to you? Can someone describe what end up happens to you when you have polio?
Your nervous system is destroyed, and your muscles don't get messages, so they become like a trophy, and
They
they
atrophy.
can't. I mean, they atrophy, yes, sir, and they can't. They're paralyzed in a certain position, or it may cause.
It may cause them to. It may cause them to die.
Die.
Yeah. Okay. So paralyzation happens with people with polio. you become paralyzed, and or you may end up dying. So that's not good. It really affects the spinal cord. And yeah. Okay, then we have the regular ones, which is a strain. And a strain is, anyone ever had a strain before? This is when you scratch, this is when the muscle is scratched or torn, right? So strain, this occurs. Say it again.
I had that.
You had that before?
Yes, sir.
What happened to cause that? How did you get that?
I had one too. I did over a rock.
You did over a rock, okay. Kiajana, you were saying something?
No, sir. That was
Okay.
somebody else. That was
Okay.
me, sir.
Oh, who is that?
Nakari.
Nakari. Oh, you said you had a strain, okay. Kiajane, where's your notes from math?
I have to send them right now. I was about to send them.
No, you stop lying. Stop lying. I've been calling you all that time. Please send in your notes. You always go. Send your notes, please. You hear me? Do you hear me?
Yes, sir.
Do you hear me, Kiajane?
Yes, sir.
Good. Send your notes. Yes, Kima.
Can I send my notes on my parents' return?
Yes, you can. This occurs when a muscle is scratched or torn rather. That's a strain. So whenever you have a muscle that is scratched or torn, that's going to be a strain. So first question, what type of disease that affects the muscular system in such a way that may cause someone to have paralysis, to be paralyzed?
Polio.
Polio, very good. Polio. And what is a problem in the muscular system that may cause someone, that occurs when someone scratches or tears their muscle?
Strain.
Strain, very good.
Train.
So you ever walk in and you end up doing your foot like this? Anyone that ever happened to someone?
Yes, sir.
All the Yes, sir.
I
Yes,
feel the
sir.
pain through that
All
picture.
the
Just
time.
gave me
You
so
could
much flashbacks.
All the time.
all the time, right? This is what we call what? A strain.
Press
Okay.
ankle. Oh,
Sometimes that's happened like when you wear heels.
It
Yeah,
does happen.
especially with heels, yes.
Oh wow, I
that
didn't.
has happened if I step down without looking where I walk.
Yeah, that's when that happens to me. All right, then the next one. It begins with C. Can y'all guess it?
Concussion.
Nope. Something very more simple than that. It happens when you
Cramp.
don't say it again.
Cramp.
Cramps. Very good. That happens when you don't, like when you're about to do physical exercise and you don't like scratch, get cramp.
Excuse me, Mr. Petit.
Go ahead.
How are you aware when you get a strain, like when you're stretching?
Say it again.
How are you aware how are you aware that you have gotten a strain by stretching a muscle?
Oh yeah, it's easy because you can feel it. It's gonna hurt. It's gonna
Okay.
hurt. Understand? So
Yeah.
for example, as you can see, this person, let me give you an example. Let me show you. So as you can see, this person, he has a strain. He end up tearing his muscle or overly scratching it, and as you can see, it causes pain, and he has to hold his leg, right?
Yes,
I
sir.
don't know if you ever see when persons are playing basketball, and they do a particular move, and then they have to stop playing the basketball and go off the court and go, go in the back and have an ice rub or something like that.
Yes, sir.
because
Is it normal for that
Yes,
to
sir.
happen when like you laying down in bed and you stretching and then you just get a cramp and you can't move your leg, or is that just me?
I think that's normal. I think that happens to everyone. I mean, maybe to you more at a maybe more so because of you, but that happens to everyone. Like if you wake up in the bed in the wrong position and you scratch, yeah, you can end up getting a cramp or something like that. So these occur. So cramps, these usually occur when skeletal muscles are overused, little oxygen, so little oxygen gets into the muscle, inhibiting respiration. Now, when you have little oxygen getting into the muscles, what's that's gonna happen is it's gonna cause a buildup of lactic acid. So this causes lactic acid to build up in the tissue, right, of the muscle. That's cramps. So give me the name of a malfunction in the muscular system or something that affects the muscular system when someone muscle is scratched or torn. What do we call that?
A strain.
A strain. Very good. Question, give me the condition where your muscles are overused. We call that a cramp. Cramp, very good. And what disease of the muscular system is caused by a viral pathogen?
Polio.
Polio.
Polio. Right. Polio. Describe how a person may look if they have polio.
Their muscles will be
Common
cramped and
sight.
They what?
their muscles would hurt.
Okay, they have an abnormal bend.
Posture. Yeah.
Yeah, a normal posture. And
More commonly, they'd be seen on all fours.
yes, they'll be seen on all fours, because it affects their spinal cord. Okay. Okay, the next one is what we call spasms, muscle spasms. Right? And so spasms, anyone know what a spasm is? That's,
Is it like that sharp pain which you just get in your muscle?
yeah, like a sharp pain. It's when your muscles contract, right? It contracts rapidly, right? And continually. It's referred to as a tick, right? So it's like a fast like it on your muscles. It happens when they call it a spasm because it's a continual contraction when your muscles contract rapidly. So
Is it
occurs.
normal to have spasms in your back?
Yeah, it's normal. I mean, not normal, and it's not right. I mean, you're only supposed to have that as if you like I noticed NBA player like when you like say for example you had like surgery done in your back or you do a lot of lifting or you maybe because of your school bag, maybe if you carry a lot of books, like it usually happens when you have like when you overwork your back. That's when you typically should have muscle spasms. You shouldn't have muscle spasms out of the blue. That's uncommon. But it typically happens with persons who, they're athletes. They put a lot of pressure on their back. Maybe they underwent some surgery before, something like that. So these occurs when the muscle contract rapidly continually and is sometimes continually and is sometimes referred to as a tic. All right, then we have the next one, which is called muscular dystrophy. Muscular dystrophy. Now, this is when this is a form of, or this is a group of, when we say hereditary, what does that mean?
It's
Hereditary.
passed down from parent to child.
Very good. It's passed down from parent to child. That means that you get it from whoever your parents were. And so, or it runs in the family, right? So where muscles are destroyed gradually. This disease is this disease in some form affects all three types of muscle cells. Muscular dystrophy. So it's a type of hereditary disease in which the muscles are gradually destroyed, and that's not good, because if your muscles are gradually destroyed, that means that you end up in a wheelchair, right? And that's not good, right? It's kind of like polio, in a sense that, you know, the effects, you mean that the look is the same. So for example, this person has it, and at 2 years they look normal, but then at 8 years they begin to get this hunch in their back, and then by the time that they're 15, you have severe crippling and deformities, right? So remember, the muscles are destroying themselves. So or the muscles are being destroyed. That's what we mean by muscular dystrophy. The muscles are being destroyed. Something within their body is causing that. I don't know what's causing that exactly, but it's when their muscles are being destroyed. And so if you don't have muscles, remember, muscles helps with movement. So if that's not working, then obviously you wouldn't, you know, you wouldn't be in a healthy condition. And so, yeah, I figured it happened because of mutations in a person's genes. Yeah, so it's happened because it's caused by mutations in a person's genes. So something went wrong with your DNA, and it causes you to have inherited conditions whereby the muscles weaken gradually. All right. So it's a progressive muscular degeneration. So it happens over time, and over time, you know, the muscles get destroyed, they become weak, and you know, you end up not being able to stand and stuff properly. Okay, which type of muscular disease which type of muscular disease is caused by a viral pathogen?
Polio.
Polio, very good. Polio. Which type of muscular condition is caused because of an overuse of the skeletal muscles?
Cramps.
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 In which type of muscular condition we have the muscles contracting rapidly? Spasms, very good. And in which type of muscular condition we have the muscle being scratched or torn?
Strain.
Strain, very good. And then the last one I'm going to give you for this evening. The last one is going to be cerebral palsy. Now, some of you may heard that. Some of you have heard that word before, right? Cerebral palsy. Cerebral palsy. Anyone ever heard that before? Cerebral palsy.
Yes, sir.
No, sir.
Ever heard
Yes,
of
sir.
it? So that's when you have your brain being damaged, right? So it happens from when you are in your mother's womb. So cerebral palsy is usually caused by damage to the brain while the fetus was in the womb. And the muscles in the body have various degrees of movement depending on the amount of brain damage occurred or incurred. So basically, your brain from your wound was damaged, and your brain controls different parts of the muscles. And so with your brain being compromised, your body does not function in the right way. So cerebral palsy, you want to have limited range in motion, right? It's just like polio, just like muscular dystrophy. They're gonna be in a wheelchair because the brain is not functioning properly. So that means that it cannot tell the muscles to work and operate. So looking at something like this is someone who has cerebral palsy. As you can see, they are limited to the wheelchair and they can't control their muscles. All right. All right, you understand that?
Yes.
Yes,
Okay,
Yes, sir.
good. Okay, good. So question, which type of muscular condition happens or occurs when we have a damage to brain in the fetus?
Cerebral palsy.
The cerebral palsy. Very good. Good. All right, so that brings us to the end of health science. I need you to take a picture of your work and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp. And then we can move on to general science, all right? Yeah, we can move on to general science afterwards. Again, take a picture of your work and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp. So that we can move on to general science.
Mr. Petit, may you send the notes in the chat, please?
Yes, I can. Let me put the notes in the chat for those of you who are still writing.
Excuse me, Mr. Petit, can I send my work when mommy is done with that phone, please?
Yes, we can. Again, take a picture of your work and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp. Oh yeah, and take a picture of your work and send it to me via WhatsApp. So we can move on to general science notes.
Good night, Mr. Boutique.
Good night. All right. So for those of you who are still here, we have to do, we have to continue our journey on solutions and suspensions. We said that a solution has two parts to it. What are the two parts of a solution? If you remember, the two parts of a solution.
The solute and
The
solvent.
solute
The
and
solute
solvent.
and the solvent. Very good. Today is the 5th of March, 2024. The topic is, the subject is subject is general science. And the topic is solutions and suspensions. Well, we're only gonna be talking about solutions. So types of solutions. So what is the part that is being dissolved? What is that? What do we call that? The part that is being dissolved.
The solute.
The part that is being dissolved. What do we call that? The solute or the solvent? The part that is being dissolved.
The solute.
The solute. Very good. The part that is being dissolved is called the solute. How about the part that does the dissolving? What do we call that?
Solvent.
The solvent.
Solvent.
Yes, the solvent. So the part that is being dissolved, we call that the solute. The part that does the dissolving is what we call the liquid part, which is the solute, the solvent. All right, the solvent. So then there's that. So we're going to be looking at types of solutions. So we're going to look at what do we call an aqueous solution. Now let's define that aqueous solution. So the aqueous solution, as its name might suggest to you, when we say aqua, what does aqua mean? Like
Water?
water. Very good. Like Aquaman, you know, aquamarine, right? Aqua means water. So aqueous solution have something to do with water, right? So is one, it's a type of solution that contains a substance dissolved in water, right? For example, an aqueous solution. Write this down for me, please. For example, an aqueous solution of sugar. When we say an aqueous solution of sugar, that means that the sugar is dissolved in what? Means that the sugar is dissolved in what?
The water?
Is dissolved in water. Very good. It's dissolved in water. So aqueous solution is one where the main substance, the substance that is being, the substance that does the dissolving or the solvent is what? Water. So what if I say an aqueous solution of salt? What does that mean?
That's where the salt is being dissolved in the water.
Very good. That means that the salt is being dissolved in the water, right? So aqueous solution is where the substance that is being dissolved is being dissolved in water. All right. Aqueous solution. Then we have just one type. So where's Ajani? Ajani, are you there?
Yes.
Ajani, I noticed that you don't like to send in these health science and general science notes. Where are you?
Yes, sir.
Do not do any type of shortcut tonight. Make sure send your health science and general science notes. Do you hear me?
Well, my pen ran out of ink, but I still wrote some health science notes.
No, no, no. Stop lying, man. Stop lying. Stop lying. The rest of the notes are inside the chat. So what you need to do is you need to find something to write with, whether a pen or pencil, and write it down. Do you hear me?
Yes, sir.
I know you have a trick up your sleeve. How do I know it? Because you do it every week. You need to write down all of the notes. Do you hear me?
Yes, sir.
And the same thing applies to everyone inside the chat. Don't you dare leave this class without sending in the notes. Do you all hear me? The rest of you.
Yes, sir.
Yes, sir.
Yes, sir.
I don't understand why you're here if you're not going to send in the notes. It doesn't make any sense. So make sure that you have all of the notes for me because I do look at these pictures. And if you don't have the notes sent in, you don't need to be here. Because it means that you're wasting time. All right, so aqueous solution is one where the substance that is being the substance that does the dissolving is the substance that does the dissolving is water. All right, then the next one we have is a dilute solution. So dilute solution. This is a solution, is one in which a small amount of solute is dissolved in a large amount of solvent. That's what we mean by dilute solution. A small amount of solute is dissolved in a large amount of solvent. That's what you mean by dilute solution. A small amount of solute is dissolved in a large amount of solvent. So if that means that, so for example, if we have if you have tea that is diluted, right? What does that mean? That means that, hey, it doesn't have enough sugar or it doesn't have enough tea. So if we have a dilute solution, it means that our solutes are not concentrated, right? It doesn't have a large amount of it. So, and dilute means to make something last. So for example, if I say, hey, man, this thing too strong, dilute it for me, right? Dilute means to add more solvent so that the ratio of solvent and solution, it will be such that the solvent is more, like there's more of the water in it, or there's more of the liquid part of it. So dilute means there's a small amount of solute and a large amount of solvent. All right. So Amarnik, what do we mean by dilute solution?
It is one in which a small amount of solute is dissolved in a large amount of solvent.
Solvent, very good. And Chai, what do we mean by dilute solution? Chai?
It's one in which a small amount of solvent is dissolved in a large amount of solvent.
Very good. Small amount of solute is dissolved in a large amount of solvent. That's what we mean by dilute solution. Okay. Then we have obviously the opposite of that is going to be a concentrated solution. So concentrated solution. Now a concentrated solution is one, it's opposite of dilute, is one in which we have a large amount of solute is dissolved in a small amount of solvent. So we mean by concentrated solution. We have a large amount of solute dissolved in a small amount of solvent. So that's what we mean by dilute. I mean concentrated. So small amount of solute for this one. This one we have a large amount of solute. So which type of solution has a large amount of solute? Which type of solution has a large amount?
Concentrated solution.
Very good, concentrated solution. Kyle, where's Kyle? Kyle, are you there? Where's Kyle? Kyle, are you there? We can't hear from Kyle. Kevin. Where's Kevin? Casey and Kevin, are you there?
Yes, Sister Bettina.
Where's your brother? It's disconnected what? Yeah. Stop
Excuse me,
lying.
Sister Bettina.
Stop lying. Listen, sir, I don't believe you. What I need to do is answer me when I call your name. You hear me? Okay, so
Mr.
Kyle,
Bettina.
one moment, Kyle. Where's Kyle?
Yes, sir. Yes, sir.
What's the name of a solution that has a small amount of solute? Small amount of solute. What is that?
Yes, sir.
What's the name of a solution that has a small amount of solute? What do you call that type of solution? Where we have a small amount of solute.
Excuse me, Mr. Bettina. If you said something to me, I can't hear you.
What's the name of the solution that has a small amount of solute? Can anyone help him? What do we name call the solution that has a small
Concentrated solution.
small amount of solute?
Dilute solution.
Dilute solution.
Dilute solution. Very good. Udon, where's Udon?
Right here, sir.
What's the name of the solution that has a large amount of solute?
Concentrated.
Concentrated solution. Very good. And Dante, where's Dante? Dante, are you there?
Yes, sir.
What's the name of the solution that has a large amount of solute? What do we call that? If it has a large amount of solute, what do you call that?
Contracted solution.
Concentrated solution.
Concentrated solution.
And Akiro, what is the name of the solution that has a large amount of solute, Akiro?
Pardon me,
Akiro,
Mr. Biddy. Pardon me, yes, sir.
what's the name of the solution that has a large amount of solute?
Concentrated solution.
Concentrated solution. Are you writing down the
Concent-
notes?
Not, yes, sir, yes, sir.
You sure?
Yes, sir.
So where are they? I don't have them.
I said right now in general science, so.
You need to take a picture of your notes and send it to me. Okay, so concentrated. Now, next type. So non-aqueous solution. So non-aqueous solution. What does that mean? That means that the solvents has solvents other than, we could say, the solvent of this solution is not water. So can anyone think of a solution that they know where the solvent is not water? Can you think of solutions?
Non-aqueous solution.
It is a non-aqueous solution, but give me an example in real life.
Milk.
Milk,
Soda.
soda, but soda is water.
Alcohol.
Corn syrup.
Corn syrup. Anyone know? Anyone
Honey?
ever? Say again.
Mayonnaise.
Honey?
Mayonnaise, honey. Okay. Anyone familiar with acetone?
Yes, sir.
Yes,
Yeah.
sir.
The nail polish remover?
Yeah, nail polish remover, right? So acetone, that is a solution. That is a type of solution where the base or the solvent is not water. What's the base or solvent for acetone? It's acetone. So we have acetone, and this one's not acetone, but acetone is one. That's a nail polish remover. Let me give you examples. One already said it. When you have alcohol could be a solvent. So examples would be ethanol. Ethanol dissolves iodine. We also have petrol dissolves what? If you have like grease or paint, petrol dissolves that. So petrol dissolves grease and paint, right? And then we have acetone, which is a nail polish remover. Acetone dissolves nail polish. And then carbon disulfide dissolves sulfur. and turpentine dissolves grease and paint. Now, I bet you these are unfamiliar to you, right? Probably it's the first time hearing these words. And the reason is because these are usually it's water that dissolves stuff, right? It's kind of weird not to hear water. But it is true. You can have you can have solutions whereby water is not the solvent. For example, ethanol could be the solvent, petrol could be the solvent, acetone could be the solvent in terms of nail polish, carbon disulfide could be the solvent if you're trying to dissolve sulfur, and turpentine can be the solvent when you're trying to dissolve grease and paint. So those are some, you know, those are some solvents that are not water, all right? Ethanol, petrol, acetone, carbon sulfide, carbon disulfide, and turpentine. Those are different solvents that's not water, okay? So give me an example of a solvent that is not water.
Ethanol.
Ethanol, very good.
Maple syrup.
Maple syrup. Okay, yeah, maple syrup.
Acetone.
Say it again.
Acetone.
Acetone, very good.
Nail polish.
Turpentine.
Acetone, which dissolve nail polish. Go ahead. Turpentine, carbon disulfide, right? Those are different.
Petrol.
Say it again. Petrol, yeah, petrol, which dissolve.
Petrol.
Petrol would dissolve grease, right? So those are different types. What do we call the solution? Well, what do you call the type of solution that in which water is not the solvent?
Non-aqueous.
Non-aqueous
Right.
solution.
Yes. Non-aqueous. Very good. Non-aqueous. All right. Okay, good. That's all the notes we have for this for science. If you have already taken a picture of it, send it to me via. If you've already finished with this, take a picture of it and send it to me via WhatsApp. Again, once you finish, take a picture of it, send it to me via WhatsApp. Again, once you finish with your work, take a picture of it and send it to me via WhatsApp.
My work.
Okay, good. Once you finish your work, then you can leave. Again, once you finish your work, then you can go.
Good night, Mr. Petit.
Good night. Make sure to take a picture of your work before you go.
Good night.
Good night.
Good night, Mr. Petit.
Good night.
Good night.
Good night.
Good night.
Good night.
Good night, Mr.
Good night.
I sent in all my work. Good night, Mr. Petit.
Good night, Mr. Petit.